Given a keyword, the web crawler will then search through the pre-designated websites. It will search through the major websites in every regional language so that different viewpoints across the countries and across different sections of the society will be covered. First, before searching, the given keyword will be matched against some word embeddings so that we can find the required and related tags. For example, let's look at the word demonetization. If we look up for demonetization, the related tags which will show up are finance, marketing, and cash. This will be helpful in selecting the articles relevant to our task. It will also help us in identifying the department which needs to be informed about the negative news so that they can take prompt action. However, we also need to search through other sources like e-newspapers. E-newspapers are usually stored as images in the web for many different regional websites. So what we first need to do is extract the text from those images, which is present in regional languages, and we then give it to the same natural language processing module, which performs sentiment analysis. We also need to keep track of YouTube videos released by major news organizations so that their captions or transcripts of the videos can be analyzed, which should also be done by the natural language processing model. Now let's look at this NLP module. This NLP module is actually a transformer pipeline. Transformer is the architecture which we use for converting the sequence of our text which was extracted to a particular sequence which will not be understandable by the humans yet, but this particular sequence will then be given to a classifier model or an artificial neural network, which will then classify the sentiments into three types: positive, negative, neutral. It can also be given to another decoder instead along from the output from the encoder, so that it can generate a report which will be then used in the first server as we saw before. Now looking at the database requirements of this, the database requirements are quite straightforward since we just need to keep track of the users, the websites which we need to track, etc. However, storing images and videos is a different ballgame. Here, we will leverage cloud fundamentals, which will help us in storage management. We will also store the different reports so that they can be referred to by the organization at any point of time, along with their interaction with the deletion module of our first server. Let's look at our stack. We have used HTML, CSS, Bootstrap, and JavaScript, which is a classic stack for front-end development, along with React.js library, which is a JavaScript library. We have written front-end in TypeScript since it allows us type security. We have written backend using Django, which is a Python library, since Django is a direct Python framework, and Python allows us to schedule calling of the different models present in our system without scheduling it ourselves and going too much into the low level details. We have used MongoDB since it will allow us to leverage both data NoSQL database scalability and cloud features at the same time. We have used TensorFlow package to create the required models along with Beautiful Soup, which will handle web scraping even for dynamic websites. Government policy monitoring is one of the major use cases of our product, since the response of the people is important to the government so that they can plan next major steps. It is also useful for monitoring different media organizations and how they interact with the government along with how they report on the issues, since we also maintain a global score for them. It is also useful for real-time notification since there is a system, as we can see in the automatic process, which if for example any query regarding the department has not been made for some time regarding a set timer, then our module will run automatically by itself and it will call the crawler and other required components so that the related tags to the departments will automatically be searched first through the web and a report will be generated so that any prompt action will not be missed. There is also a user-friendly dashboard so that any PhD officer will not have any qualms using our website, and they can easily search for a particular report using our fast search engine. What are the showstoppers? The major difficulties will be handling language variability, since human language is very complex and our model will be quite large at that. And as we know, different websites will have different formats, and web scraping, to discourage web scraping, a lot of websites will employ many techniques which need to be accounted for, and especially dynamic rendering needs to be taken into consideration when web scraping. Determining the relevant sources of information to extract from is essential, since it is impractical to extract information from everything in the web. Determining relevant department to the task is also a must, since other departments shouldn't be disturbed and only the relevant department should be notified. Uh, This is a hugely computationally expensive system, so the space and both computational power needs to be optimized properly. Let's look at our features which will make our system unique. As we all have already seen, automatic real-time monitoring system, which will automatically search for tags related to a department even when a query is not given at a particular intervals, which is customizable, so that prompt actions can be taken. A detailed report will be generated along with sentiment analysis. This can be done by employing a different decoder along with the original decoding or transformer model, so that they can be used for future analysis. Organizations can also be profiled so that a score can be maintained, so that the history of the organization along with the context of the news can be taken into account in the future. As we have already seen with the periodic delete, space optimization is a must, and if the user chooses so, the periodic deletion will be employed along with using the detailed summary reports generated to still maintain the required data needed. The main dependencies will be using the Google APIs for searching and scrolling through the web scraping tools which need to be complex enough to search through dynamic render websites, pre-trained word embeddings which need to be optimized to our tasks, and also YouTube API.